Hello, my name is Les Pounder. I am the Associate Editor at Tom's Hardware. I'm also a freelance hacker and maker, especially for Raspberry Pi stuff. I can't be there in person tonight, very sorry. It's absolutely chock-a-block at work at the moment. But I wanted to show off a board that's been particularly influential in my career. And that board is Explorer Hat Pro, which is on screen right now. This board is fantastic. I have delivered, I think, about 20 plus Pi Academy training sessions, the Raspberry Pi Foundation's official training course, when I used to be an instructor for them. 20 plus sessions, so that's over 600, maybe 700 teachers that I've taught how to use this board. Fantastic, and for 20 quid it's well worth the money. So, quick whistle stop tour around what the board can do. The board fits on top of the Raspberry Pi. It uses the 40-pin GPIO Raspberry Pi, so that's all of the current models. The only one that's not compatible is the older original Raspberry Pi. It has lots of inputs, lots of outputs. Input-wise, we're going to look at numbers 1, 2, 3 and 4. And they are capacitive touch inputs. They're buttons, basically. If I was to touch one of those numbers, it would correspond to a key press and it would perform some action that I programmed. If I go to buttons 5, 6, 7 and 8, those are capacitive touch inputs such as makey makey. So I can attach conductive objects to those, and I can have them as inputs that react to my touch on that object. So bananas are the common one to use. Spoiler, there might be a banana later. Just above the numbers 1, 2, 3 and 4, you'll see some little cutouts. Those are for LEDs. Those LEDs are mounted on the underside of the board, and they are red, yellow, green and blue, and they just shine through with a nice glow. You'll see those in a minute as well. Just above the numbers, we have 1, 2, 3 and 4, we have inputs and outputs. 4 analog inputs are present, so you can connect up electronics such as temperature sensors, that sort of thing, potentiometers, and use voltage input so we can see how much voltage is coming through. That's how analog works. So we can have an input range of say 0 to 1 volt, it will perform this task, 1 to 2 volt perform this task, and then 3 to 4, 5, that sort of thing. We've got some standard digital inputs, 1, 2, 3 and 4 there. We've got 2 5 volts and 2 ground connections, that's just power. Outputs, we have 1, 2, 3 and 4, you can see just above number 3. 4 outputs which are pulled to ground, so when you turn them on it pulls to ground, so you put your ground connection to there. And you can have anything you want on there, LEDs, sensors, whatever, it doesn't matter. And finally, we've got some motor connections. We can connect 2 motors. We've got an H-bridge motor driver on this board, which means we can plug in motors. Spoiler, there's a motor in a minute. So we can make robots, and most of the Pi Academy sessions I led had robots built using this board. There are some extra connections. Just on the right hand side we can see some 3 volt connections. They're really just breaking out the I2C, SPI and serial UART to use. I don't really use them, but they are there if we need them. To top it all off, we've got a breadboard on here, so you can breadboard our projects directly on top of the Pi. Saves a lot of space. So let's have a look at it in action. So I'm going to go to my code, and this is written in Python. You can write it in Python. There is a library as well for Node-RED, and I believe there's something in Scratch as well, but I haven't used that for a long time, so your mileage may vary. In Python, I've just done a really simple project. I'm just going to do it line by line, but really quickly because this is quite boring sometimes. Line 1, I import the Explorer Hat library, but I rename it as EH because it does become quite cumbersome to type in Explorer Hat all the time. I make the mistake all the time, Explorer Hat, stuff like that, missing out the L. So I just do it that way. The sleep function is used just to add a little bit of pace to the code so I can control how fast something happens. While true, so the loop's going to go round and round. If, the first if we come to, if Explorer Hat's touch interface, number 1, so the button 1, so remember that is the number 1 there. If that is pressed 3 times, so for I in range 3 times, and then 4 times, because there are 4 LEDs, each light, so 0, 1, 2, 3, turn on for 0.1 of a second, then turn off for 0.1 of a second. So it'll do that 3 times. So it'll do all the lights, red, yellow, green, blue, 3 times. If touch interface 5 is pressed, oops, that's me pressing the wrong button on there. It's on this I need to press. If touch interface number 5 is pressed, print 5 on the screen for debug so I can see it's working. I had a little problem, so I had to tweak it. 3 times. Turn the motor on forwards at half power. So 0 to 100, 0 being off, 100 being full power. I'm just going to do half power, 50%, sleep for 2 seconds, then go backwards, same speed, 2 seconds, then add a stop. Always add a stop when you're doing robots, otherwise it drives off the table and you can't catch it. So how am I going to show this off? Well, we go to my overhead cam and we have a banana, not for scale. Well, it could be. Explorer hat is on a Raspberry Pi 4, just because it's what was on the desk. Crocodile clip to the banana, to connection 5. And I've got a motor underneath my big vanity business card here, held up with lots of blue tack. And I'm going to run this code, so you can see it running. So I'm going to go back to my code, I'm going to click Run. And it'll say Explorer Hat Pro has been detected. Okay, so let's go back to the overhead camera. And I'm going to press number 1. And if you just look at the lights above 1, 2, 3 and 4 here. Can you see them? I'll do it again. Yeah, that's a nice proof of concept. It works. But what we really want to see is that spinning because I've touched that. Okay? 3, 2, 1. It's like those spinning signs you see on the streets in America, but made with a banana. And there is the stop, so it stops the motor from spinning. So that's Explorer Hat Pro. Fantastic little board. There is a cheaper version, the Explorer Hat Fat, or Explorer Fat, I think it's called. 12 quid, which is made for Raspberry Pi Zero. Brilliant board, it just omits the capacitive touch interface. Still has the motor drivers, protected inputs. Basically, it's got all of what's above 1, 2, 3 and 4. It's got all those connections. But for 20 quid, this is a great board, and I've used it. This is now 5 years old, this board, at least. But these new, well, these ones now, brilliant boards. And if you've got 20 quid burning a hole in your pocket, get one. It is great fun. As I say, it's fantastic fun just to tap a banana and have something happen. You can link this into Minecraft if you wanted, with a bit of Python. You can make robots, you could have temperature sensors plugged in to monitor that and send the data over MQTT or some other IoT platform. It is just exceptionally simple to use. And with just a few lines of code, you can build a pretty interesting project really quickly. That's all from me, apart from to say if you'd like to visit my blog, you can. It's bigl.es, Big Les. Or you can go to tomshardware.com and have a look at the Pi projects on there. Thanks very much, have a nice night.